Welcome to Metrology lecture series. In the present video, we will discuss the errors in screw threads. Errors in screw threads can happen during manufacturing or even during the storage. A screw thread has the 6 important elements, and if there is any one of them having the error, then thread may be the rejected. So let's see what are the important 6 elements of the screw thread. First one is the major diameter. Major diameter is the outer diameter of the screw thread. And minor diameter. Minor diameter is the inner diameter or root of the thread. And next element is the effective diameter or pitch diameter. Effective diameter is the diameter where the thread thickness equal to the space between the threads. And next element is the pitch. Pitch is the distance between two consecutive threads. Next element is the flank angle. Flank angle is the angle of the sides of thread. And last element is the profile at crest and the root. Shape at the top and bottom of the thread we are calling as the crest and the root. So next we have to discuss about the why these errors are the important. So first we have to discuss about the if the error in the major diameter, it will be cause for the interference with the matching of the thread. Moreover, it can reduce the proper contact between the threads, and also in the internal threads, it may be weaken the component. So next we have to discuss about the what is the important of the minor diameter error. Minor diameter error causes the interference, and also it will be reduce the proper contact between the threads, and also may weaken the thread by reducing root strength. Next one is the effective diameter error. It controls the fit between the threads. So it may be the tight or may be the loose. If the effective diameter is the too small, for the external thread become the thin and internal thread become the thick. Similarly, if the effective diameter is the too large, then opposite effects it will be occur. So for the external thread become the thick and the internal thread become the thin. Similarly, effective diameter error can cause the noise and improper fitting during the operations. And the next one is the pitch and flank angle errors. These errors are cause for the tightening or interference during the assembly, and moreover, it will be cause for the threads may not fit this smoothly. And moreover, another error is the radius at the crest and the root. The top and bottom of the thread should have the proper smooth curves. It will help in reducing the stress concentration and improving the strength. So next we have to discuss about the pitch error. So pitch error is the error in the spacing of the threads measured along the axis of the screw. Let's see how the pitch error will be occurs. So we know that when the threads are usually made by the using a single point cutting tool on the lathe machine operation. So in this regarding the operation, there are the two important motions are there. One is the rotation of the workpiece or angular velocity of the workpiece, and second important motion is the forward movement of the tool or maybe the linear velocity of the tool. So for the correct threading, the tool must move forward by exactly one pitch distance for one full rotation of the workpiece, and also this ratio must be the accurate and the constant. So if this condition is not satisfied, then pitch errors are the occurs. So next we have to discuss about the what is the mean of the cumulative pitch error. So cumulative pitch error means where small pitch errors add up over the entire the length of the thread, it is called as the cumulative pitch error. So next we have to let's see the various types of the pitch errors. First one is the progressive error. Progressive error means error increases gradually along the thread. For example, each thread spacing becomes a slightly larger or maybe slightly smaller. Second type of the pitch error is the periodic error. So periodic error means error repeats at regular intervals. And this periodic error caused by machine defects. And next one is the drunken error. In the drunken error, threads does not follow a proper helical path. So drunken error appears like a wavy or distorted thread. And the last type of the pitch error is the erratic error. So this erratic or irregular error is the random errors with no fixed patterns. In general, it is caused by the vibrations or maybe the tool wear or some disturbances. Next, we will discuss the progressive errors. Progressive pitch error occurs when the pitch of the thread is consistently larger or smaller than the correct or nominal value. And this error increases gradually along the length of the thread. So in the simple terms, progressive error means each thread spacing is slightly wrong and this error keep on adding step by step. Let's see the main causes of progressive error. First one is the incorrect speed ratio. If the wrong ratio between the tool movement and workpiece rotation, then progressive error will be occur. And next cause is the lead screw error. Inaccuracy in the machine's lead screw pitch, then progressive error will be occur. Next, third cause is the incorrect gate time. If the wrong or approximate gears are used during the threading, then it will be produce the progressive error. And next cause is the faulty in the guideways. If there is any problem in the saddle movement of the machine, then it will be produce the progressive error. And next to last cause is the material changes. If there is any changes in the material's point of view in the length due to the heat treatment, obviously it will be produce the progressive error. So these are the causes for the progressive error. So next we have to see the how the progressive error is behaves. This progressive error is uniform but accumulates along the thread. And the representation of this progressive error is on the graph is cumulative pitch error versus the thread length. So in the schematic you have to see here we are representing the progressive error. So in the y-axis we have to considering the cumulative pitch error, and in the x-axis we have to considering the thread number or the thread length. And here progressive error is it is the linearly varying, it is increasing from the start point to the end point. So progressive error is happens when the tool and work speed ratio is the constant, but we are maintaining the wrong amount of the this tool to work speed ratio. So let's take the example. So if the actual pitch is the 1.02 mm, but actual requirement is the 1 mm. So actual requirement is the 1 mm, but we are maintaining the 1.02. So let's consider the for the first thread. So error is the 0.02 and it is the very small. And let's consider this progressive error for the 10th thread. So we know the progressive error is the accumulate continuously along the thread. So for the 10th thread it will become the 0.02 into 10, then it will become the 0.2 mm. So it is the somewhat bigger amount of the error. And let's consider the 100th thread. So for the 100th thread, it will become the 0.02 into 100 and it will become the 2 mm. So it is the very large error. So this error is keep on increasing continuously along the thread number. Next we will discuss the another pitch error, that is the periodic error. So what is the periodic error? So this error is a type of error which repeats at regular intervals along the thread, and some thread portions are the longer and some thread portions are the shorter than the correct value. So in the schematically I have to see this one. So here, so this is the some periodic error, continuously it is the varying, and for the certain thread it is having the so small value, and for certain threads it is having the so very large amount of the error. So it will be vary. So in the simple terms, this error is the so comes and goes in a pattern. So it is the very certain pattern. So next we will discuss the how this periodic error it will be occurs. So these errors are happen when the tool and work speed ratio is not constant. If you are not maintaining the constant tool speed and the work speed ratio, then this error it will be occur. This causes to the pitch is it will be increase up to a reach a maximum value, then it will be decrease when reach a minimum value, and this pattern is repeats continuously. Next we will discuss the causes of this periodic error. So first cause is the non-uniform speed ratio. If the tool and workpiece speeds are not constant, then it will be rise the periodic error. And second cause is the lead screw problems. If the lack of the proper alignment and also lead screw moves slightly forward and backward in the each rotation, then it will be occur the periodic error. And third cause is the eccentric gears. If the gears are not mounted properly, then rise in the periodic error. And next one is the gear tooth errors. If there is any imperfections in the gear tooth, obviously it will be produce the periodic error. And next cause is the lead screw errors. If there is any inaccuracy in the screw itself, then it will be produce the periodic error. And next one is the worn the thrust bearings. So this worn out of these thrust bearings causes for the unwanted axial movements, then it will be produce the periodic error. So how to represent these periodic error in the graph sheet. So graph of the cumulative error versus thread length we have to represent. So in the schematically here we are representing this periodic error. So on the y-axis we are representing the cumulative pitch error, and in the x-axis we are representing the thread error. And here I have to observe, so this error it will be increases up to the maximum value, then it will be reduces to decreases to the minimum value, and once again this is the repeated. So pattern of this one is the sinusoidal or maybe the wave shaped pattern, and this pitches is increases up to the maximum value and it decreases up to the minimum value, and this pattern is repeated the again and again. And let's see the key difference for the progressive error and the periodic error. So in the progressive error, this error is increases continuously. In the graph we are representing the straight line graph, but this periodic error, so this error is increases and decreases repeatedly, and we are representing as the wave in the graph sheet. Next type of the pitch error is the drunken error. So first I have to discuss about the why it is calling as the drunken. So just imagine the walking style of the drunken person. So drunken person walking is in a not in a straight line. His walking style is in a zigzag or the curved path. So similarly, drunken error means for a normal thread, it is having the straight helix. But in the drunken thread, this is having the curved helix. In the schematic also have to observe. So for the drunken thread, so it is having the helix is the curved helix. But in the normal thread, this helix has a straight helix. So drunken errors mean, so drunken error is a special type of the pitch error where the error is repeats one in every revolution, and this error is measured along the axis is the correct, but the thread is not following a true helical path. So it is will be this helix path is the varying. So for the drunken error, pitch is the correct, but helix shape is vary. So for the normal thread, helix shape is a straight line, but in the drunken error, helix shape is the incorrect. And this drunken error is the repeats and it is once per the revolution. So let's see the what is the effect of the performance if it is any thread having the drunken error. So usually these drunken errors are not very serious for the normal screws, but it causes certain problems in the large diameter screws and precision applications. So let's see the comparison with the periodic error. In the periodic error, pitch itself vary. It may be longer or maybe the shorter. But in the drunken errors, pitch is correct, but helix is not a true. So next we have to discuss about the another pitch error is the erratic or irregular pitch error. So let's see the what is the irregular pitch error. Irregular pitch error is a type of error which changes randomly along the length of the thread and which has a no fixed pattern or a repetition. So in the previous three type of the errors having the fixed pattern and it is a repeating. But for the irregular pitch errors, it will be changes randomly and there is a no fixed pattern. So in the simple terms, we have to say the irregular pitch errors mean. So it is the this pitch error is a unpredictable and the scattered. So let's see the what are the main causes for the this irregular pitch error. First cause is the machine parts. So if there is any problems in the machine parts or improper functioning. A second cause is the non-uniform material. So in the materials point of view, variation in the material properties which causes the uneven cutting. And the another cause is the disturbances during the machining. So these disturbances mean in the terms of the vibrations or maybe the loose setup or the sudden changes during the operations. These irregular pitch error it will be produced. So next see the how the behavior of the if any thread having this irregular error. So there is a no regular increase or decrease and there is a no repeating pattern. And also graph also look like a random and irregular. And let's see the what is the effect on the threads mean. So it will be produce the poor accuracy and also effects on the smooth assembly and performance, and moreover it is very difficult to detect and the control. So this is the pitch error and also errors in the screw thread, and thank you.